All right, this lesson starts on page 72, and the following table contains the steps for a new magic number puzzle. For each column, follow the steps to find the ending number for the given starting number. All right, so we are given a starting number of 2, multiply it by 3, add 12, and then divide by 3. So let's try it with 4. 4 times 3 is 12, and then we're adding 12. That'll give us 24. And then we're dividing by 3, which is 8. Negative 7 times 3 is going to be negative 21. Add 12. So remember, we're down 21. We need to go up 12. So that'll get us to a negative 9. And then divide by 3, which will be a negative 3. And for pick your own number, why don't I do number 6? Okay, 6 times 3 is 18. 18 plus 12 is 30. And then divide by 3, 10. What is always true about the ending number in this puzzle, no matter what number you start with? About the ending number, no matter what number we start with. So we start with 2, end with 6. Start with 4, end with 8. Start with negative 7, negative 3, and then 6 and 10. So going from 2 to 6, we would be adding 4. 4 to 8 would be adding 4. Negative 7 up 4 would be negative 3. And then 6 to 10. So looks to me like we take the beginning number and add 4 to get the ending number. All right, for 3, write down a number. We've got a number n, and then we're going to multiply that by negative 2. So when they say write down a number, they want us to be using n to represent the number. So when we multiply n by a negative 2, we are going to have a negative 2n. Because remember, when they sit right next to each other, that means multiply. And then they want us to add 5 to that. So then we will have negative 2n plus 5. Write down a number n, add 5 to it, so n plus 5, and then multiply that by a negative 2. Okay, so remember, we're not just multiplying the n by a negative 2, we're multiplying the whole thing. So I'm going to put the negative 2 first, and then I'm going to put in parentheses the n plus 5 to show that we are multiplying negative 2 with both the n and the 5. For each of the following shape equations, determine whether the equation is true or false. All right, well, these shapes throw me off. I don't think I can do it with shapes. I need actual numbers. So I'm going to just assign some really easy numbers here. So let's say the rhombus is a 1. So go through and mark rhombus with 1 on everything, on all the rhombuses, or rhombi. Is that how you say the plural of rhombus? And let's make the square 2. And we've got circles, so let's make circle 3. Working with some easy numbers. Okay, so 1 plus 2 is 3. 2 plus 1 is 3. So, sorry, door's opening. 3 equal 3. Yes, that is a true statement. And so we know that for addition, for the explanation here, we know that for adding or addition, we can switch numbers, or Yeah, and switch around numbers. Okay. Then let's take a look at this one. 1 minus 2. Well, if I have 1 and I'm going down 2, I'm going to end up with a negative 1. But for 2 minus 1, we get 1. Well, is negative 1 the same thing as 1? No, it is not. So for subtraction, we can't switch the numbers. Okay, let's look at multiplication. 1 times 2 is 2. 2 times 1 is 2. 2 equals 2, so this is a true statement. So we know for multiplication, we can switch the order of the numbers. And now let's take a look at division. 1 divided by 2. Okay, we could turn that into a decimal if we wanted to, but we could always write it as a fraction also. So I'm going to write this as a fraction. 1 divided by 2, because remember that fraction line means divided by. Equals 2 divided by 1. Well, 2 divided by 1, 1 can go into 2 times. So that's actually a 2. So is 1/2 the same thing as 2? No. So for division, we can't switch the order of the numbers. All right, so remember with PEMDAS, we have to do parentheses first. So 1 times 2 is 2, times 3 would be 6. And then over here we have 2 times 3 is 6, times 1. 6 times 1 is 6. So now we have 6 equaling 6. True statement. So we know for multiplication, we can switch the order of the numbers. All right, let's take a look at addition. 1 plus 2 is 3. 3 plus 3 is 6. 2 plus 3 is 5. Plus 1 is 6. 6 equals 6? Yes. So for addition, we can switch the order. All right, then down here in number 1, they want us to be using n for the number, just like they did up here. So we choose a number, n. We are multiplying n by -2, so we'll have -2n. And then we are subtracting 9 from it, -2n minus 9. So the magic number expression is going to be -2n minus 9. For the next one, choose a number n, and we're going to be subtracting 7 from it. So n minus 7. And then we're going to be dividing by 5. So you got to be really careful here. We got to divide this whole thing by 5. So we can write it as a huge fraction, n minus 7 over 5. And so our magic number expression is n minus 7 over 5. All right, and then next was page 75. All right, we have our number n. We're multiplying it by 4, so that will look like 4n. And then we're adding a -5 to it. So we'll have our 4n, and we could write plus a -5, but having the plus sign in there is not helpful. So we can just shorten this by having -5, because -5 means the same thing as -5. Here's our number n. We're going to multiply by -2, so we'll have -2n, and then we're going to subtract 6 from it. negative 2n minus 6. Write down a number n, subtract 6, so we'll have n minus 6. And then we're going to be multiplying it by a negative 2. So remember, we have to multiply this whole thing by negative 2. So let's put n minus 6 into parentheses, and we can have the negative 2 out in front to show that we are multiplying the negative 2 with the n, and also the negative 2 with the negative 6. And then we have some definitions. All right, for variable, my understanding of what this term means. A variable is a letter that represents a number. So if we have like y equals 2x plus 5, that is a variable, and that is a variable. Y is a placeholder of a number, and x is a placeholder of a number. All right, for algebraic expression and algebraic equation, these two are very, very similar. An algebraic expression does not have an equal sign. So it could be like x plus 2, y minus 7. That would be an algebraic expression. But an equation does have an equal sign. So that would be like 2x plus 3 equals y, or 9y minus 4 equals 17. They have an equal sign. And that's it for this lesson.